Welcome friends, Igor is here, and in this video we will discover a systematic procedure for describing infinite solution sets. In this lesson, we will define dependent and free variables, come up with a bulletproof procedure for describing infinite solution sets, and use it to describe an infinite solution set for one sample linear system. Let's get started. Let's take this linear system of 4 equations in 7 variables. We know how to solve any linear system. We find the augmented matrix of this linear system, and then we reduce the augmented matrix to the reduced row echelon form using the Gauss-Jordan elimination algorithm. Here is the result of this reduction. This is the reduced row echelon form of the augmented matrix of the linear system. Let's analyze this reduced row echelon form matrix. First of all, we see that R is equal to 3. There are 3 non-zero rows, which means there are 3 leading ones, which also means there are 3 pivot columns. The pivot columns are columns 1, 3, and 4, and non-pivot columns are all the other columns, the ones that do not have the leading ones. And now, let's use this reduced augmented matrix to find the solutions of the original linear system. We are going to look at each of the 3 non-zero rows of the reduced augmented matrix, write the corresponding equation, and solve this equation for one variable, the variable that corresponds to the pivot column. The first row corresponds to the following linear equation, and in this equation it is the variable x1 that is in the pivot column. So what we do is we solve this equation for the variable x1. We express the variable x1 in terms of all the other variables in this equation. In the second equation, it is the variable x3 that corresponds to the pivot column, and we solve this equation for the variable x3. Finally, we do the same for the third equation. It is the variable x4 now that is in the pivot column, and we solve this equation for the variable x4. What we've done is this. We expressed all the variables that correspond to leading ones in terms of the other variables, the variables that do not correspond to leading ones, the variables that do not correspond to pivot columns. And the reason we solved each equation for the variable that corresponds to the leading one is this. Each such variable appears in exactly one equation. This comes from one of the properties of reduced row echelon form matrices. The leading one is the only non-zero value in its column. Look at the equations on the right-hand side. All variables that appear on the left-hand side never appear on the right-hand side. In other words, they do not depend on each other. They depend only on the other variables, the ones that do not come from pivot columns. But now, if we assign any specific values to the variables that appear on the right-hand side, we will obtain a particular solution of the entire linear system, because value of those variables will dictate the values of the variables on the left-hand side. The variables that appear on the right-hand side come from non-pivot columns, and because they are free to assume any values, we call them free variables. Conversely, the variables that appear on the left-hand side come from pivot columns, and we call them dependent variables because they depend on the values we assign to the free variables. Moreover, once you choose specific values of the free variables, this results in one solution of a whole linear system, because fixing values of free variables uniquely determines the values of the dependent variables. Now we are finally ready to write the infinite solution set. We replace each of the dependent variables with the corresponding expression in terms of the free variables. And the free variables remain as is. Also, this set notation indicates that all free variables are free to assume any values in complex numbers. Now, using this systematic approach, dependent variables that come from pivot columns are expressed in terms of the free variables that come from non-pivot columns. We can describe any infinite solution set. If you found this video useful, please like and subscribe to help others discover this content. In the next video in this series, we will derive a simple test whether linear systems have any solutions. I will see you later.